we have to find the voltage Vc across the capacitor and the current through the resistance, 8 ohms resistance. Now when we look at this circuit at t is greater than 0, so somewhere there was a switch that was closed, and we are assuming that right after t is equal to 0, what's happening with the transient, because in this circuit we see there is no voltage source, and the capacitor has an initial voltage which is the capacitors at V is equal to 0 is given as 60 volts. So that voltage will decay through the resistances. So we have to find the Vc, the expression for Vc, as well as the current I and Vr, which is the drop across this 6 ohms resistance. So first if we look at the voltage source, how the capacitor, how it will decay, how its voltage will decay through which path, we can see that we have a parallel combination of 12 and 6, and then resistor R 8 ohms is in series. So the R here, so if we look at for this one, the equation will be, the decay equation will be for the capacitor will be like that. So this is at t is greater than 0. Now V0 is the initial voltage which is given as 60 volts, and R is the resistance through which it will decay. Now that resistance is 12 parallel 6 plus 8 series 8. So 12 parallel 6 is 12 into 6, 12 plus 6 plus 8, which is 4 plus 8, so 12. This one is the effective R. So Vc will be V0, which is 60, minus e to the power minus t over 12 into 1/3. So if I calculate the RC, that will be 12 into 1/3, because the capacitor is given as 1/3 farad, so that will be 4. That will be just 4. So 60 e to the power minus t over 4, which is 60 e to the power minus 0.25 t. So the time constant is 4, and it is in the denominator like that, so it becomes 0.25 t. So that's the Vc here. When we look at Vr, it will have the same decaying rate, the same time constant, because the time constant is defined by that RC. The voltage the Vc's voltage will decay. So what will happen is a fraction of this voltage will decay here. So this one is the parallel. So this voltage here, the voltage across 6 volts and 6 ohms and 12 ohms. So we can see that the voltage Vr will be Vc, of course, the same Vc which is there, this Vc, and then the total resistance is just from using voltage divider rule. So that will be 8 plus 4 and times 4, because that resistance is 4. So it will become 12 and 3, so it will be 1/3 of the same thing. So 60 e to the power minus t e to the power minus 0.25 t divided by 3, that will be 20 e to the power minus 0.25 t. That will be the expression for Vr, which is across this resistance, 6 ohms resistance, or actually 12 ohms as well, 12 ohms resistance as well. And then we have to find this current, which is the current it is going into the capacitor, but the actual current will be in this direction, because this is the plus and this is the minus, like this bent plate is the negative. So the current will go through this way, so go this way. So I will be, of course, a negative value. So it will be the voltage, which is again Vc, divided by the equivalent resistance, which is of course 4. So that will be again 60 over 4 e to the power minus 0.25t. The equivalent resistance, it's 12, sorry, the equivalent resistance is 12, so it will be Vc over 12, so that will be negative sign because the direction is negative the other way, so negative, and 60 over 12 is 5 e to the power minus 0.25t. So basically the time constant is always the same, only this value, the coefficient will be different depending on across which resistance the voltage is, or depending on current of which branch we are trying to calculate. So yes, this is